Hi everyone, welcome to the first of the questions from the chapter in the complex numbers of De Moivre's theorem and Euler. So we've only got 3 examples left to cover, so this video will show you how to do the first example. So this video also has the lecture slides are also on the My Place page, as well as just the written solution of this as well, all typed. So this video is more of an explanation of how we got to where we did. So without further ado, we'll get started. So the first question we've been asked is to use De Moivre's theorem to simplify the following expression. So the reason it says expressions here is because there's 2 examples. One is in the lecture examples and the solution of that, but it's much more complicated, so I would encourage you to do that in your own time, and if people have problems with it, email me and I'll do another video going through that one as well. Okay, so we've used De Moivre's theorem to simplify root 3 plus I to the power of 7. So what do we do first? So to begin with, what we're going to do is we're just going to consider the root 3 plus I without anything. So what we do is we first of all find the magnitude of that complex number. So remember, the magnitude of any complex number is simply the real part squared plus the imaginary part squared, square rooted. So in this case, the real part is the root 3 and the complex part is I, so it's just a 1. So that means that when we put that into our formula, we get the square root of root 3 squared plus 1. Now, any square root squared is just itself, so root 3 squared is just 3. So we've got 3 plus 1, square root of 4, which is equal to 2. So that's the first thing we do in any of these questions, is we always find the magnitude of our vector. Now the next thing we do is we draw our diagram. So remember, we think of these as being coordinates. So we're going root 3 along in the horizontal and up 1i. So we're going along root 3 and plus I. So we're in the first quadrant here. So remember, the first quadrant angle, that's just the relative acute angle. So all we do is we do tan inverse of our y component over our x component. So the y component corresponds to the imaginary part, which is 1, and the real part is the x, which is root 3. So we've got 1 over the square root of 3, and that gives us pi by 3. Now, if you were to do this in your calculator, it's not going to come out as a nice number as being pi by 3. It's going to come out as something much more horrible. It's going to come out as approximately 1.047. Now, it's important that you know your exact values and how to calculate those. So what you might want to do is, if you're struggling with radians, you might want to do inverse tan of 1 over the square root of 3 and do that in degrees, and that'll come out 60. And then in your head, convert that to radians, because remember, we're not allowed to write any degrees on the exam script, okay? So that's how you would get round that in the examination. Okay, so now what do we do? So what we do now is we write this in the polar form. Remember, the polar form is just the size times by the cosine of the angle plus I sine of the angle. So root 3 plus I is equal to twice the cosine, pi by 6, plus I sine, pi by 6. Now, that would be us finished if we didn't have this power of 7 here, but we've still got a wee bit to go, okay? So what we need to do now is we need to implement De Moivre's theorem. Now, De Moivre's theorem says that if you've got cosine theta plus I sine theta raised to any power, what you do is you bring down the power and you multiply it by the angle. So for us, we have twice cosine, pi by 6, I sine, pi by 6 to the power of 7. So the 7 as normal just raises that 2. So we've got 2 raised to the power of 7, and then we're timesing our angles. We've got our pi by 6 times 7 for our cosine, and similarly for our sine, pi by 6 times 7 as well. So what we're going to do in the next slide is we're going to tidy that up. So 2 to the power of 7 is 128, and pi by 6 multiplied by 7 is just 7 pi by 6. But we have a problem, and remember in lectures we talked about this, how we can't have a top-heavy fraction. That's a problem for us. So how do we fix that? So when we have a top-heavy fraction, we'd subtract off 2 pi. So we're going to be doing 7 pi minus 2 pi. So what I've done here is I've rewritten 2 pi with the same denominator. So it's got a denominator of 6. So we've got 12 pi over 6, and that's equal to minus 5 pi over 6. So now we no longer have a top-heavy fraction. So that's the next thing we do. So then what we do now is we go back to where we were and we rewrite our 7 pi over 6 with our minus 5 pi over 6. So now what we need to do is, now that we've replaced 7 pi over 6 with minus 5 pi over 6, we need to simplify this equation, because our final answer here should be a real plus imaginary number. So it should be in the form a plus ib. So what do we do now? We need to make use of our cast diagram, this all sine tan cos, or the Sex and the City diagram. So what we have here is, I've drawn the diagram SATC. So A means all, S is sine, T is tan, and C is cosine. So what I've done is, if I start at my horizontal line and go round 5 pi by 6, I end up in the third quadrant. Now the third quadrant, where the green tick is, has a T in it. That means that only the tangent of the angle is positive in that quadrant. But since we've got cosine and we've got a sine of an angle, they don't start with a T, so that means that they're both negative. So that means that the cosine of minus 5 pi over 6 and the sine of 5 pi over 6 are negative in the third quadrant. So that means whatever answer we get out is going to be negative. So what do we do now? Well, cosine of the minus 5 pi over 6 is equal to minus root 3 over 2. And similarly, sine of 5 pi over 6 is equal to minus 1/2. We know that these are both negative from the previous slide, so when we do this in the calculator, we just make sure that our solution is negative. And then what we do now is we just replace cosine of minus 5 pi over 6 with minus root 3 over 2, and similarly we replace sine of minus 5 pi over 6 with minus 1/2, and that's done in the next slide. So all I've done is I went back to where I was, this 128 cosine minus 5 pi over 6, and I've replaced my cosine of minus 5 pi over 6 with minus root 3 over 2, and I've replaced the minus 5 pi over 6 with my minus 1/2. So note there should be an I after the half. That's just missing from there. So just add that in. And then all I've done here to get this 64 is I've just taken out the common factor of the 1/2 and times all that out. Notice we've got a plus multiplied by a minus, so that's going to become a minus I. And that's that question all finished. So all done. Okay, so there's another 2 videos for the next 2 questions, so I would encourage you to watch those. Okay, thank you so much. See you later, guys. Bye.